Okay, question 7, we have a graph. There's a circle around the origin, and we have a ray that's dropped at theta degrees. And there's our coordinates. It'll show us the values on this right triangle that's been made. So we've gone back 1/2. So the side length here is 1/2 or negative 1/2. And then we've gone down negative square root of 3/2. And because this is a right triangle, we can use the Pythagorean theorem to find the length of the radius or the hypotenuse. So let's start with there. These sides will be our A and B. The hypotenuse is always C. So I have negative 1/2 squared plus negative squared root of 3/2 squared. And that will be C squared. So you can include the negatives or not. When you square them, they go positive. So it doesn't really matter if you put the negatives in or not. I will, but it doesn't change the answer. Okay, so we still get 1. So C squared is 1. If we take the square root of both sides, we get C. So this is our typical unit circle if it has a radius of 1. Let's start with cosine. So cosine is adjacent over hypotenuse, and our adjacent side is right here next to the angle at negative 1/2. The opposite is across from the angle. So negative 1/2 over 1, which would just be negative 1/2. So if I want to find angle W, I'm going to use this right triangle with that cosine value. And I'm going to take the inverse cosine of both sides because that's the opposite of cosine itself and leaves me with just W. So cosine of negative 1/2, or inverse cosine of negative 1/2, is 120. Sorry, I should have done positive because our side lengths are positive, right? So this is actually 60, not 120, sorry. When you're looking at lengths, you want to be using positive values. So just think of a random, not a random, but a right triangle that we just found. Let's make this 1/2 positive and that positive when we're finding the angle. So W is 60, and you can see what theta is just from the picture. 180 plus W, which is 240. Okay, so 60 cosine is negative 1/2, 60 and 240.